In this video, I'm going to discuss answers for questions related to parallelograms. Before everything, we need to understand what a parallelogram is and the properties of a parallelogram. Right? දැන් ඔක්කොටම කලින් මොකක්ද parallelogram එකක් කියන්නේ කියලා අපි ඔළුවට දාගන්න වෙනවා. ඒ වගේම parallelograms වල තියෙන properties. එහෙම නැත්නම් ලක්ෂණ මොනවද කියලාත් අපිට තේරුම් ගන්න වෙනවා. Right, now in simple terms, a parallelogram is a quadrilateral. What is a quadrilateral? It's a four-sided closed plane figure, right? Precisely, a quadrilateral is a closed plane figure bounded by four straight line segments. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel, right? So the first point that you should keep in your memory is opposite sides of a parallelogram are parallel, right? They are parallel. So let's mark it. Now, if you consider these two sides, these are opposite sides. And also, if you consider these two sides are actually opposite sides, right? Now, if I label this parallelogram A, B, C, D, A, B, and C, D are opposite sides. So they are parallel means normally we denote this using arrowheads like this. Now this AD side and BC side are also opposite sides, AD and BC. So they are also parallel, right? So we can use two arrowheads, right? So a parallelogram is a quadrilateral with both pairs of opposite sides are parallel is called a parallelogram. Now the next point that you have to remember is the opposite sides of a parallelogram are equal. Now when you consider AB side AB and side CD, these two sides are equal in length. Also the other two opposite sides are equal in length. So I can write like this. AB equals CD and AD equals BC. Okay, so this is one of the main properties of a parallelogram, right? Then the next point. The opposite angles of a parallelogram are also equal. So what are the opposite angles here? Right, now if you consider this angle and this angle, these are opposite angles. So these two angles are equal in the magnitude. So angle A equals angle C. And also the other two opposite angles are also equal, right? So angle B equals angle D. Now let's say if this is 100 degrees, this should be 100 degrees. If angle A is 80 degrees, this should be 80 degrees. Okay, the next point is the area of the parallelogram is bisected by each diagonal. Right, now when we draw the diagonals, right, like this. Now these are the diagonals of this parallelogram, right? If I name them, it's AC and BD, right? Now it says area of the parallelogram is bisected by each diagonal. Right, now if you consider diagonal AC, right? Because of this diagonal AC, this area of the parallelogram is exactly equal to the other part, right? If this area is, let's say, A, then definitely the other part also A. The area of the other part also A. Therefore, the area of ACD, triangle ACD equals area of triangle ABC. And on the other hand, the area of triangle ABD equals the area of triangle BCD. Right? So that's the third point that you should remember. Right? The fourth point. In a parallelogram, the diagonals bisect each other. Now, these are our diagonals, the blue color lines, right? Now, because of the diagonals, this length and this length is equal. And also, on the other hand, this length and this length should be equal. So if I write this, I can write like this. Let's put O here, right? The intersection point, the middle. AO equals OC. Also, DO equals OP. So first of all, you need to understand these properties, the properties of a parallelogram. Right, now, apart from these properties, remember these points as well. Now, when you add angle A and D, where is angle A and D? A is here and D is here. So when you add these two angles, you get 180 degrees. When you add these two angles, you get 180 degrees. Similarly, if you add this angle B and angle C, again you get 180 degrees. So these angles are called allied angles, right? These are called allied angles, right? Now also, right, if you add angle A and angle B, you get 180 degrees. Similarly, if you add angle C and D, again you get 180 degrees. So remember, this equals 180 degrees. So these angles also are called allied angles. A and B, and also C and D, right? So keep this point as well, because this is important for you to solve certain questions. Right, next you should know about the theorems related to parallelograms. Okay, so theorem 1, right, and theorem 2, actually I discussed. These are the properties of a parallelogram, right? So opposite sides are equal in a parallelogram, opposite sides are equal, opposite angles are equal. Then the area of the parallelogram is bisected by each diagonal. And as the second theorem, in a parallelogram, the diagonals bisect each other. Right. Now, the other theorems below are the converse theorems. Right? These are the converse theorems. For example, if you take the first one, it says, if the opposite sides of a quadrilateral are equal, then it is a parallelogram. Let's say if you are given a quadrilateral, and if you are given that this quadrilateral's opposite sides are equal like this, that means this quadrilateral is a parallelogram. Okay, so similarly, if you take the next theorem, the converse theorem, the opposite angles of a quadrilateral are equal. If the opposite angles of a quadrilateral are equal, then it is a parallelogram, right? If the given quadrilaterals opposite angles are equal, then it should be a parallelogram. Right. The next one, If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So if you are given that the diagonals of this quadrilateral bisect each other, then it should be a parallelogram, right? That means these two lengths should be equal and these two lengths should be equal. Right. Lastly, the last theorem, it is again a converse theorem. In a quadrilateral, if a pair of opposite sides is equal and parallel, then the quadrilateral is a parallelogram. Now, according to this theorem, let's say you are given a quadrilateral with a pair of opposite sides which is equal and parallel, like this. Let's say if we consider these two opposite sides, if they are equal and parallel, definitely this is a parallelogram. Or if you take the other two opposite sides, if they are equal, right, and parallel, definitely this is a parallelogram. Okay, so these are the theorems related to parallelograms. Okay, now what I do is I'm going to discuss certain questions from your textbook exercises. So first of all, I'm going to discuss the exercise 16.2, question number 4. Right, now in this sum it says PQRS is a parallelogram. ඒගොල්ලෝ clearly කියනවා මෙන්න මෙයා parallelogram එකක් කියලා. නේ? Right. එතකොට parallelogram වල properties අපිට මතක් වෙන්න ඕනේ මේක parallelogram එකක් නම්. Then they say points X and Y lie on PR such that PX equals XY equals YR. Here is PX. This equal to XY. Also equal to YR. So that's why they have put these dashes. Right. Then we need to prove that QX equals SY. Where is QX? It's over here. SY is here. So මේ දෙන්න equal කියලා අපිට prove කරන්න ඕනේ. Then බලන්න මේ sides දෙන්න pink color sides දෙන්න ඉන්නේ මෙන්න මේ triangles අස්සේ නේද? Triangle එකේ side එකක් විදිහට නේද? Right? මේ triangles දෙන්නගේ sides තමා මෙන්න මේ දෙන්න. එතකොට මේ දෙන්න equal කියලා prove කරන්න නම් පුතා ලේසියෙන්ම අපිට කරන්න පුළුවන් දේ තමා මේ triangles දෙන්න congruent කියලා prove කරන්න try කරන එක. ඒතර හැමතිස්සෙම මතක තියාගන්න මේ වගේ parallelograms එනකොට ඔයාට sides දෙකක් equal කියලා prove කරන්න දුන්නොතින් හොඳම දේ ඔයා බලන්න ඒ sides දෙන්න ඉන්නේ triangles දෙන්නෙක් නම්. ඒ sides දෙන්න ඉන්නේ triangles දෙන්නෙක්ගේ නම් ඒ triangles දෙක congruent කියලා prove කරොතින් easily ඔයාට ඔය දීලා තියෙන sides දෙන්න equal කියලා prove කරන්න පුළුවන් වෙනවා. Right. එතකොට බලන්න මේ triangles දෙන්න කවුද? මම පොඩ්ඩක් erase කරලා ඔයාට පෙන්නන්නම්. මේ triangles දෙන්න තමා දැන් අපි හොයාගත්තු දෙන්න මෙන්න මේ දෙන්න. හරි. එතකොට මේ දෙන්නගේ congruency එක prove කරන්න පුළුවන් නම් ඔන්න අපිට ලේසියෙන්ම SY and QX කියන sides දෙන්න equal කියලා prove කරන්න පුළුවන්. Right. So let's write. Let's take this triangle first and this triangle next. So we can say in triangle PXQ and triangle what? The other triangle, second triangle, let's call it SRY. SRY. Right? So you can easily say this px equals yr. Why? It's the given data here. So you can say px, let's say, yeah, px equals yr within brackets, it's given. And then you can say that if you consider now this is a parallelogram, no, right? If this is a parallelogram, these two sides should be parallel, right? If these two sides are parallel, you can take this angle and this particular angle as alternate angles. Why? This PR acts as an transversal, isn't it? This PR acts as a transversal. Right. එතකොට මේ angles දෙන්න ඔන්න මේ වෙලාවේ equal. මේක ලියමු. මම initiate වෙන්නේ PXQ angle එකෙන් නිසා මම එයාගේ elements තමයි මුලින්ම ලියන්නේ. ඒ කියන්නේ මෙන්න මේ angle එක. So this angle we can name it how? You can say XPQ, right? XPQ. Oh, yeah. Equals this angle, let's call it YRS, right? YRS, or you can say SRY. Let's say SRY, right? SRY. And what are these two angles? You can say these are alternate angles. Right, next. Now, since this is a parallelogram, these two sides should be definitely equal. Right, so you can say that PQ side equals SR side, right? So these are actually opposite sides of a parallelogram, and opposite sides of a parallelogram are equal. So let's write. Now see, there are three pairs of elements, two pairs of sides and one angle, right? So we can say easily that these two triangles are congruent. So what's the case here? Two sides, two pairs of sides, one pair of angle, that means SAS. So what's this angle? Can you see? This angle, these are the two sides. So this angle is which angle? Is the included angle, right? හරි දැන් ඉතින් අපිට easily කියන්න පුළුවන් මෙන්න මේ දෙන්න equal කියලා. ඇයි? මේ දෙන්න congruent triangles දෙන්නේකේ corresponding elements. So you can say SY equals, therefore, here so you can say therefore SY equals, sorry, let's write other way around because මේ විදිහට එන අහලා තියෙන්නේ නේද? QX equals SY. Within brackets, you can say corresponding elements, or you can say specifically these are sides. So corresponding sides of what? Congruent triangles. Right? Within Roman figure 1, then යමු අපි Roman figure 2 වලට. Roman figure 2. 2 වල කියන්නේ same two sides. හැබැයි මේ දෙන්න parallel කියලා අපිට prove කරන්න වෙනවා. Right. මේ දෙන්න equal. එක අපි කලින් prove කරා. දැන් මේ දෙන්න parallel කියලා prove කරන්න ඕනේ. Right. දැන් බලන්න මෙන්න මේ angle එකයි මෙන්න මේ angle එකයි. Right? මේ දෙන්න definitely equal නේද? Why? These two are corresponding angles of congruent triangles. Then මේ triangles දෙන්න congruent නේ, right? 1 and 2, right? එහෙනම් මේ දෙන්නගේ corresponding elements අනිවාර්යෙන් equal වෙන්න ඕනේ. හරි? එතකොට බලන්න මේ angle එක එකට equal ඒ වගේම මේ angle එක පුතා මෙන්න මෙතන කවුද PXQ. ඒ angle එක තියෙන්නේ හරියටම straight line එකක් උඩ. හරි? එහෙනම් අපි දන්නවා නේද sum of the angles on a straight line equals what? 180 degrees. එතකොට මේ 180 degrees වලින් මේ angle එක අපි deduct කරලා ලියලා දාමු. හරි? ඔන්න මම ලියන්න ගන්නවා. Let's write. First I'm going to say that these two angles are equal. What are the angles? PXQ. Right? PXQ කියන්නේ මෙතන මෙයා. ඊට අමතරව මේ කවුද අනිත් එක්කෙනා? SYR. It's this one. So why I say so? Because these are corresponding angles, or you can say elements of congruent what? Triangles. Right? Then I'm going to write this one. හරි? 180 degrees වලින් අයින් කරනවා කියලා පෙන්නනවා. 180 degrees වලින් PXQ අයින් කරාම වාට ඉතුරු වෙන්නේ මෙන්න මේ angle එක නේද? හරි මේ angle එකට අපි name එක දෙමු. කවුද මේ? QXR නේ? Or you can say QXY up to here, right? QXY. QXY. Right? මෙයා QXY නේ. හරි? හරි. ඒ වගේම අපි අනිත් පැත්තත් එහෙම ගමු. අර මෙන්න මේ SYR angle එක අපි deduct කරමු 180 degrees වලින්. මොකද once again මේ angle එක තියෙන්නේ හරියටම මෙන්න මේ pink color straight line එක උඩ. එහෙනම් පුතා මෙන්න මෙතන angle එකයි මේ angle එකේ sum එක 180 degrees. එහෙනම් මට 180 degrees වලින් මේ angle එක අයින් කළොත් ඉතුරු වෙන්නේ මෙන්න මේ angle එක. How to label this? Let's say SYX, right? OP වෙනකන් යන්න පුළුවන්. Right. දැන් හොඳට බලන්න මම පොඩ්ඩක් erase කරන්නම් මේ set එක දැන්. කරලා අපි කතා කරේ මෙතන angle එකයි මෙතන angle එකයි equal triangles දෙක congruent වෙන නිසා ඊට පස්සේ 180 degrees වලින් අයින් කරාම මෙන්න මේ angles දෙක ආවා අපිට. දැන් පුතා මේ දෙන්න equal නේද? හරි. right. දැන් හොඳට බලන්න මම try කරන්නේ මෙන්න මේ sides දෙක parallel කියන්නනේ. හරි? ඒතර මං හොයාගන්නවා දැන් මේ angles දෙන්න equal කියලා. දැන් මේ angles දෙක ඔයා බැලුවොත් මේ size දෙකත් එක්ක ඔයාලට පේනවා ඇති මේ xy transversal විදිහට act කරනවා. කරලා මේ angles දෙක අපිට පේන විදිහට මොනවද මේ? alternate angles කියලා පේනවා. ඉතින් මේ angles දෙන්න alternate angles plus මේ angles දෙන්න equal කියන්නේ alternate angles equal. Alternate angles equal කියන්නේ පුතා මේ sides දෙන්න automatically parallel වෙනවා. Right? So we can write like this. Therefore, QX parallel to, right, SY, right? It's SY because alternate angles are equal. You can say alternate angles are equal. If alternate angles are equal, then these two lines should be parallel. Okay, that's it. Okay, now let's read the next question. The figure illustrates a parallelogram ABCD. ABCD කියන්නේ parallelogram එකක්ලු. Right? This one, this figure is a parallelogram. Right? Now you should recall the properties of a parallelogram now. Right? Then the points X and Y lie on the sides AD, BC respectively. AD is here
and X lies over here, right? Then BC is here and Y lies here, right? Such that dx equals by, right? That means these two sides are equal, right? These two sides are equal and it is our data. Right, now what's our requirement? Prove that ABY triangle equals congruent, actually congruent DCX triangle. Right, now where are these two triangles? ABY triangle is here. The other triangle is over here. So you should prove that these two triangles are congruent. Right. Already you know two things. Right? We know that dx equals dy and it's given. Right? And also we know that this whole figure is a parallelogram. හරි ඉතින් දැන් දේශයෙන් අපිට මේ triangles දෙක congruent කියලා prove කරන්න පුළුවන්. Right? Right. So let's write in triangle APX, this one, and triangle DCX. Right. Let's write the given data. Right? dx equals by. dx equals by. So this is Roman figure 1. And this is given. Okay. Right. Now what else? Since ABCD is a parallelogram, we can say that this angle and this angle are definitely equal. Why? Opposite angles of a parallelogram are equal. මතකයි නේද parallelogram එක property එකක් මේක. Right? Parallelogram එක opposite angles හැම වෙලාවෙම equal. Right, now let's interchange these sides and right, because first of all we need to write whatever the sides and angles of XBY triangle, right? So XBY කියනකොට එතන එන්නේ BX කියන side එකනේ. ඒ නිසා එක මුලින් ලියන එක හරි මේ තමයි හොඳ. Right? So let's interchange. Let's write in the other way around. by dx, right? And then these two angles, right? Let's write them. So I should initiate with this triangle. එතන මම මුලින්ම ලියන්නේ ABY කියන triangle එකේ තියෙන elements. Right, ABY, the angle, how do you tell it? ABY, right? ABY angle. Angle ABY equals this angle, right? CDX. CDX. So why these two angles are equal? Because opposite angles of a parallelogram are equal. That's right. Angles of a parallelogram are equal. Right. Next, again, since this is a parallelogram, you can say that this side equal to this side. Why? Opposite sides of a parallelogram are again equal. නේ? දැන් මේක parallelogram එකක් නම් අනිවාර්යෙන් opposite sides සමාන වෙන්න ඕනේ. Right? So I have to initiate with this triangle. So I'm going to write AB, right? AB equals CD, right? CD, and this is because opposites opposite sides of a parallelogram are equal. Right. Now, what's the case? A pair of sides, a pair of angles, another pair of sides. So this is SAS case. නේද? මේ triangles දෙන්න congruent වෙනවා SAS කියන case එක යටතේ. Right? So we can say therefore triangle ABY is congruent to triangle DCX under SAS case. Right. So we proved the first part. Now it's the second part. Show that AY is parallel to XC. Right. Now where is AY? AY is here. And XC is here. Right. Then මේ දෙන්න parallel කියලා අපි prove කරන්න තියෙන්නේ. Right. Now what පේනවද? මේ sides දෙන්න ඉන්නේ quadrilateral එකක් කියලා. Right? මේ දෙන්න මෙන්න මේ quadrilateral එකේ sides කියලා පේනවද? එතකොට මේ quadrilateral එක parallelogram එකක් කියලා අපිට prove කරන්න පුළුවන් වුණොතින් අනිවාර්යෙන් අපිට prove කරන්න පුළුවන් මේ sides දෙන්න parallel කියලා. නේද? Right. දැන් ඒකට තමයි අපි try කරන්නේ. Right? Now we know that this AD is parallel to BC. Right? Why? The whole figure is a parallelogram. Right. So I'm going to write it. AD equals BC. Right? These two sides are parallel because ABCD is a parallelogram. Right? So we can say opposite sides of a parallelogram are equal. Then what else can we say? Right? Now I'll label this one as number 1. Right? And then we can also say that this given data, right? dx equals by. dx ඉන්නේ මෙන්න මෙතන. Right? ඒ වගේම by ඉන්නේ මෙන්න මෙතන. Right? අර අපි කලින් parallel කියලා කියපු sides දෙන්නට overlap වෙන්න තමයි මේ දෙන්න ඉන්නේ. Right? එතකොට මම මෙයාව label කරනවා 2 කියලා. Second one. Right? Now if I deduct dx from AD and by from BC, what do I get? I get this remaining side. This side. Isn't it? හරි දැන් මම කොහොම හරි try කරන්නේ මේ quadrilateral එකේ තියෙන elements ගැන කතා කරන්න. Right. So if I write like this, I deduct 2 from 1. Right? So let's write AD minus dx equals BC minus by. Right? So I get this remaining length and it is xy. Right? And here cy. හරි නේද? මේ length එක AD full length එකෙන් අයින් කරාම side එකෙන් අයින් කරාම අපිට මේ කොටස එනවා. ඒ වගේම තමයි යටත්. මෙතන. හරි? So we have already proved that ax equals cy. Right? Now let's erase everything and focus. We have already proved that this side and this side are equal. Right? And then what about these two sides? Right? These two sides, they are already equal. Why? Because these are corresponding sides of these two congruent triangles. නේද? අපි මේ triangles දෙන්න already congruent කියලා දැන් prove කරලා ඉන්නේ. ඒතර අපිට කියන්න පුළුවන් මේ sides දෙන්න මෙයාගේ sides මේ triangles දෙන්නගේ sides ඒ දෙන්න කොහොමත් equal වෙනවා. මොකද අර triangles දෙන්න අපි congruent කියලා මේ වෙලාවේ prove කරලා තියෙන්නේ.
Right. Now, let's write like this. Let's take this particular quadrilateral, right? So I'm going to write like this. In, right? How do we label this quadrilateral? It's not a parallelogram. We are trying to prove it as a parallelogram. In a XCY quadrilateral, chaturashraya, quadrilateral, right? Quadrilateral. What do we know? Already we have proved that AX equals to CY, right? It is actually proved, isn't it? Proved. And then this, you can say AY equals CX, why? Because these two sides are corresponding sides of these, these two congruent triangles. So let's write like this. You can say corresponding elements. So I'm going to write corresponding sides of congruent triangles. Okay, so we have proved that the opposite sides of this quadrilateral are equal. That means for sure this is a parallelogram. Why? It is one of the properties of a parallelogram. The opposite sides of a parallelogram are equal, right? එහෙනම් කෙලින්ම මේක parallelogram එකක් කියලා දැන් අපිට කියන්න පුළුවන්. මොකද opposite sides ඇවිල්ලා equal කියලා අපි prove කරලා තියෙනවා. So we can say AXCY is a parallelogram, and therefore we can say that AY is parallel to XC. So that's our answer. Right. In the next question, it says this figure shows two parallelograms. Can you see the two parallelograms? Right? There are two parallelograms named ABCD and APCQ. Right? So there are two parallelograms here. And we are asked to prove that the lines AC, BD, and PQ are concurrent. Right. AC, BD, PQ are concurrent. What do you mean by concurrent? Right? Concurrent means, right, these lines pass through the same point. If these lines are concurrent, the meaning is these lines pass through the same point. Right? Then lines කීපයක් concurrent කියන එකේ තේරුම ඒ lines හැම line එකක්ම එකම point එකක් කරා යනවා. Now for this we need to draw these lines and see, right? We need to draw these lines and check whether they are concurrent or not. Okay, so let's draw these lines. Line AC, right? AC is here, right? Now, did you notice this AC, right, becomes a diagonal, one of the diagonals of this particular parallelogram, right? This parallelogram as well as this parallelogram. Did you notice it? Right? And then let's draw the other line. BD, right? Now, can you see? BD is another diagonal of parallelogram ABCD. Right. Now, there is another line. It is PQ, line PQ. Let's draw line PQ. Now, PQ, what is PQ? PQ is another, it's one of the diagonals of APCQ parallelogram. Now, can you see at this point, these lines, AC, BD, and PQ pass through this particular point, right? So let's name this point as O. right දැන් තේරුණා නේද? දැන් මේ lines අපි draw කරාම ඇඳහම අපිට පේනවා මේ හැම line එකක්ම එකම point එකක් කරා තමයි pass වෙන්නේ. ඒතර මේ point එකට මම ඕන දැන් O කිව්වා. right? ඉතින් ඇත්තටම මේ lines ඇවිල්ලා concurrent. දැන් මේක අපිට prove කරන්න ඕනේ. right, now let's prove this. Let's write like this. Now let's take the blue color parallelogram. That is parallelogram ABCD, right? So in parallelogram ABCD, what can you say? AC and BD are what? Are the diagonals of this parallelogram. So these diagonals intersect at point O, right? So let's write AC and BD diagonals. Right? මේවට diagonals නේද කියන්නේ මතකයි නේද? Parallelogram එකක diagonals කියලා මේ lines වලට කියන්නේ. So these diagonals intersect at point O, right? Point O. So we gave this name O, right? And then if you take the pink color parallelogram, that is parallelogram. Now you can use this symbol to denote a parallelogram, right? And we normally use this symbol to denote the triangle. So likewise, this symbol is used to denote the parallelogram. Okay, right. Now in the parallelogram APCQ, that is our pink color one, right? What are the diagonals? AC and PQ, right? So you can say AC and PQ diagonals, right, intersect at again point O, right? So therefore you can say, but all these three lines intersect at point O, right? So AC, right, BD and PQ all intersect at point O. So therefore you can say all these lines pass through the same point. So you can say that straight away. AB, BD and PQ are concurrent, right? Therefore AC, BD and PQ are concurrent. So learn this concept, the concurrent, being concurrent, right? Okay, that's the answer. Okay, now let's go through the next question. In the parallelogram PQRS, right, the bisectors of this angle and this angle, right, meet at the point X. Okay. On the side PQ. Okay. And in the first question, we need to draw a figure with the above information included in it. Now here we need to draw the figure. Normally we are given the figure, but here you have to draw the figure. Right, let's do it. First, we need to draw the parallelogram. Okay, here is my parallelogram. I'm going to label it PQRS, right? Then we need to draw these bisectors. bisector of PSR. PSR. Here is our angle. So we need to draw an angle bisector, right? So let's draw this. Right, then let's draw the other bisector. Bisector of PRS, right? PRS. Right, now it says these two bisectors meet at the point X on the side PQ. So we need to draw these bisectors towards PQ side, right? Then මේ bisectors දෙන්න අපි PQ වෙනකන් අදින්න ඕනේ, draw කරන්න ඕනේ. කරලා මේ දෙන්න ඔන්න meet වෙනවලු PQ side එක උඩ X කියන point එකේ. These two bisectors meet at the point X on side PQ. So this is our side PQ. And here is our point X. Right, now this is the answer for Roman figure 1. Right, what is Roman figure 2? Prove that PX equals PS. PX equals PS. Where is PX? It's here. And PS is here. And these two are equal. Right. දැන් දැක ගමන් නම් මේ දෙන්න equal වගේ නැහැ මොකද මම හරියට ඒ කියන්නේ proportionate ඇඳලා නැහැ නිකන් sketch කරලා තියෙන්නේ. So we should show that PX equals PS. Right. Now notice this. If this SX is a bisector, angle bisector of this particular angle, right? That means this angle and this angle should be equal. If I write A here, this also A, right? And then if this RX is an angle bisector, then these two angles should be equal. If this is B, this should be also B. Now, since this figure is a parallelogram, these two lines are parallel. If these two lines are parallel, we can say that this angle is again A, right? Because this angle and this angle are alternate angles. So we can write angle R S X equals, what is this angle? Angle P X S, right? And these are alternate angles because PQ and RS lines are parallel lines. Then these two angles are obviously equal and it is actually given, right? So we can write RSX, right? Angle over here equal to PSX, angle PSX, right? And this is given, right? And then obviously, can you see here you have the same angle, right? So automatically this angle and this angle becomes equal, right? And here also with the diagram we can see that this is A, also this is A, right? So we are going to write this angle PXS equals angle PSX. Right, now if these two angles are equal, if you consider PSX triangle, right, this triangle, do you recall isosceles triangle theorem and the converse theorem, right? What is this? you can see two equal angles in a triangle. So definitely sides opposite equal angles of a triangle are equal. The sides opposite these two angles, equal angles, are also equal. So if you consider this angle, what is the opposite side? It's here, PS, right? And if you consider this angle, the opposite side becomes PX. So definitely you can say PS equals PX. So it's the same thing, right? PS, here in the question it says PX equals PS. So same, PS equals PX, right? Right. In the next question, we need to prove that X is the midpoint of PQ. Now here is our PQ. And you should prove that X becomes the midpoint of line PQ. Right. Now similarly, if this angle is B, this angle should be also B. Why? Because of alternate angles, right? So you don't need to, again repeat the steps. You can say similarly, if we consider this triangle, right? Triangle XQR, right? Triangle XQR, these two angles are equal means their opposite sides also equal. So this means this triangle is an isosceles triangle, right? In triangle XQR, RQ equals QX, right? If you consider this angle, the opposite side is this, right? RQ or QR. Now, if you consider this angle, the opposite side is QX. Anyhow, can you see RQ, right? Where is RQ? Here, this side is equal to PS, right? Why? This diagram is a parallelogram. So opposite sides of a parallelogram are definitely equal, right? So you can say, but RQ equals, so you can say opposite sides of a parallelogram are equal. Now, if you notice, these two sides are the same. So automatically, these two sides become equal, right? So you can say QX equals PS. And we know that PS equals PX because we proved here, right? Here we proved, right? So you can write that. So PS equals to PX. That means definitely this PX, right? And this QX are equal. Now check this. This side and this side are equal, right? So that means definitely X is the midpoint. X should be the middle point of the side PQ. So let's write this step also. QX equals, therefore, let's say therefore, QX equals PX because all three sides are equal. හරි මේ sides තුන් දෙනාම එකිනෙකට සමාන length එකක් තියෙන්නේ. එතකොට මෙන්න මේ කියන බලන්න මේ pink color lines දෙන්න දිහා. ඒ දෙන්න හරියටම සමානයි. ඒ කියන්නේ x ඉන්නේ හරියටම මැද. ඒ දෙන්නගේ මැද. Right? Then you can say therefore x is the midpoint of PQ. Right. Let's see the next question. Prove that PQ equals 2PS. Right. Now let's clear our parallelogram and then we'll find out what this is. Right. Now PQ is this side. It equals to 2PS. Now the PQ ඇවිල්ලා PS වගේ දෙගුණයක්. twice, right? So we need to prove this. Right, now when you consider side PQ, PQ means PX plus XQ, right? Correct, right? So let's write PQ equals PX plus XQ, right? So I can say PQ equals PX plus XQ. And we know that PX equals XQ because X is the midpoint, right? So instead of this XQ, I can again write a PX, right? So PX plus PX means 2PX. And do you remember PX exactly equals to PS? Why? We proved this. Therefore, instead of PX, I can write 2PS. Right? මෙතන PX වෙනුවට දැන් PS ලියන්න පුළුවන්. ඒ කියන්නේ PQ equals 2PS, right? So this is my answer. So I just wrote, instead of PX, I wrote PS. Or instead of writing this, you can say within brackets, PX equals PS. That's why we can straight away write PS instead of PQ over here. Okay, that's the answer. Okay, now I'm going to discuss some questions from the next chapter, Parallelogram 2, chapter 17, exercise 17.1. Question number 2. Right. The midpoint of side DC of a parallelogram ABCD in the figure is P. Right. Let's see where our P is. P is here. So this is side DC. Right. This is our parallelogram. Right. The parallelogram. Right. Then it says AD and BP produced meet at E. Here, when we extend it, and BP side is here, and again when we extend it, they meet at E. Okay. Now first we need to prove that BCP, triangle BCP is congruent to triangle DPE. Right. Where is triangle BCP? BCP triangle is here, right? And then triangle DPE is here, right? So we need to prove that these two triangles are congruent. Okay. Now let's write Roman figure 1. In triangle BCP and triangle DPE, right? What can you say now? Right, now I'll erase these colors. Now, did you notice that this side and this side are parallel? So in that case, right, we can say that this angle is equal to this angle, right? And then, can you see these triangles are definitely equal? Why? Vertically opposite angles. These are actually alternate angles because of the parallel lines. And the other thing is, these two sides are equal because it's given under our question. right? So let's write. First, I'm going to write this angle and this angle, right? First of all, let's take the angle of BCP triangle, triangle BCP. So you can say PBC, angle PBC. And this one, triangle DEP, right? And these are alternate angles, right? And then the vertically opposite angles, this one, right? And this one, right? PPC, right? PPC equals DPE. And these are vertically opposite angles. And then the given data, you can say PC equals this side, right? DP, right? DP and it's given, right? Now, what's the case? This is a pair of angle, another pair of angle, and a pair of sides. So this is AAS case. So you can say therefore triangle BCP is congruent to triangle DPE. Right. So we proved the first part. Right. Second one. Prove that the quadrilateral BCED is a parallelogram. Right. Now, where is this BCED parallelogram? Now, if you join BD and CE like this, you can see there is a quadrilateral, right? B, C, E, D, right? Now, we need to prove that this quadrilateral as a parallelogram, right? Okay, so let's do it. Right, now do you remember this theorem? In a quadrilateral, if a pair of opposite sides is equal and parallel, right? Then the quadrilateral is a parallelogram. So in this quadrilateral, if we can find a pair of opposite sides which is equal and parallel, we can easily prove that this quadrilateral has a parallelogram, right? Okay, now look here. Do you remember we previously proved that these two triangles as congruent, right? As congruent triangles, right? So obviously corresponding elements should be equal. So this DE side should be equal to PB side, right? So let's write it. DE equals PC. The reason is corresponding elements of, I write for the element, it's these are sides. So let's write sides of congruent triangles. And so it's given that these two lines as parallel, right? So these are parallel, right? So we can say DE is parallel to BC, and it is given. So this BCED quadrilateral becomes a parallelogram. So it is a parallelogram. Now here you can tell the reason, saying since a pair of opposite sides is equal and parallel, this ACED is a parallelogram, right? And also it's better if you can write on top saying, now you are addressing to this particular quadrilateral. So you can say in quadrilateral BCED, right? So we are talking about the elements of this quadrilateral. So it's better if we can say on top in quadrilateral BCED. DE equals BC and DE is parallel to BC. Therefore, since there is a pair of opposite side becomes equal and parallel, we can say that BCED is a parallelogram. Okay, let's go through the next question. ABCD are two diameters of a circle of center O. Right, can you see here is the center. This AB and CD are diameters of this circle. Then we should prove that AC, B, and D are vertices of a parallelogram. Now, did you notice this AO and OB are what? They are radii of the circle, right? Similarly, this BO and OC are also two radii of this circle. Right, that means definitely these sides are equal. Right, now let's connect this AC, DB and this AD and CB. Now you get a quadrilateral, right? It seems like a rectangle. And you need to prove that this quadrilateral as a parallelogram. Right. Now, can you see in this quadrilateral, these lines, these diameters look like the diagonals, right? So you can use this theorem. What's the theorem? If the diagonals of a quadrilateral bisect each other, obviously you can see that these diagonals bisect each other. All these sides are equal. Then it is a parallelogram, right? So we can use this theorem to prove this. Let's write OA, right? This length, right? Equals OB, right? OB. So why? Radii of the circle, right? And then you can say OC equals OD. Again, radii of the circle, right? And then you can say, since the diagonals bisect each other, A, C, B, D is a parallelogram. Therefore, A, C, B, and D are vertices. Vertices of parallelogram ACBD. Okay, fourth question. In the parallelogram ABCD, the perpendiculars drawn from the point D and B, D here, B here, right, to the diagonal AC, this is our diagonal AC, meet AC at the point X and Y. Right, here is our X and here is Y. Prove that triangle AXD, where is AXD? AXD, this triangle is congruent to triangle BYC. BYC is here. Right, now can you see that this dx is a perpendicular? In that case, this angle is 90 degrees, then definitely this angle becomes 90 degrees, right? And this angle also 90 degrees. So these angles are equal, right? So let's write in triangle AXD and triangle BYC, right? This angle, that means DXA, angle DXA equals this angle CYB, and it is equal to 90 degrees, right? And it's given, right? Then, can you see these two lines are parallel because this is a parallelogram. So in this case, this angle and this angle should be equal because they are alternate angles. So let's write it. DAX equals BCY. And it is actually, they are alternate angles since AD line is parallel to BC, right? And then these two sides should be definitely equal. Why? This is a parallelogram, so opposite sides should be equal. So let's write AD equals BC. Opposite sides of a parallelogram are equal. So what's the case now? Angle, angle, side, right? So under the case AAS, these two triangles are congruent. Triangle AXD is congruent to triangle BYC. Okay, so this is Roman figure 1. Right, next question. We need to prove that dx equals by. Where is, let's find out where dx is. Dx is here, this is our perpendicular, right? And by is the other perpendicular. So these perpendiculars are equal. We need to prove that these two are equal. Now the second part we can easily prove, right? Why? Because these two perpendiculars are the sides of the congruent triangles, right? And they are actually corresponding sides, right? So you can easily say these two sides are equal because of the congruent triangles, right? So Roman figure 2, right? dx, now this dx is the opposite side to this angle, right? And this by side is the opposite side to this angle, right? So they are corresponding elements. So dx equals by because corresponding elements or sides of congruent triangles, right? Okay, next question. We need to prove that by dx is parallelogram. Right, now where is this parallelogram? I mean this quadrilateral, right? By dx. Right, now I'm going to erase everything. Right, let's draw this quadrilateral. Now if I join d and y and x and b, I can find out this quadrilateral. Okay, now we need to prove this quadrilateral as a parallelogram. Right, now already what do we know? We know that these two sides are equal, right? Now, what's the theorem that you're going to use? Now, if we can prove that these two lines are parallel, we can use the theorem. Do you remember the theorem? If a pair of opposite sides are equal and parallel of a quadrilateral, that quadrilateral is a parallelogram, right? So shall we try to prove that these two sides are parallel? Now, do you remember, if these two angles are equal, that means these are alternate angles. So when alternate angles are equal, these two lines can become parallel, right? They automatically become parallel, right? So seriously, are these angles equal? Let's find out. Now, we know that this angle is 90 degrees, right? And also, can you see this angle also is 90 degrees? Why? Here is 90, then the other side should be definitely 90 degrees. So obviously, these two angles are equal and they are alternate angles. So when alternate angles are equal, you can say that dx is parallel to by, right? Right. Now let's write it. This is Roman figure 3. So I'm writing these two angles. Angle dxy, it's here, this one, right? Equals this angle, right? It is actually b, y, x, right? And these are alternate angles. So therefore, dx is parallel to by. So we can say that this blue color quadrilateral as a parallelogram, right? Right, so this blue color quadrilateral is obviously a parallelogram now. Why? Because a pair of opposite sides is equal and parallel, right? So these are the sides which are equal and parallel. Right, let's read the next question. Two parallelograms, ABPQ. Where is ABPQ? It's here, right? And then ABRS, it's over here, right? Now, did you notice this AB side is common to both parallelograms, right? And then we need to prove that QPRS is a parallelogram. So where is this QPRS? QPRS, right? This means we need to connect these 2 points, right? So we can find out our quadrilateral. And we need to prove that this quadrilateral as a parallelogram, right? Right. Now notice this. If you consider this ABPQ quadrilateral, AB side is equal to PQ side, right? Because these are opposite sides of this parallelogram. So you can say that AB equals PQ within brackets. The reason opposite sides of a parallelogram are equal, right? And then if you consider the other parallelogram, you can tell that AB side is equal to SR side, right? So AB equals SR, again the same reason, opposite sides of a parallelogram are equal. Right, now you can see that AB is similar here. So that means definitely PQ should be equal to SR, right? So you can say therefore PQ equals SR, right? Now where are these two sides? These are inside our quadrilateral. The quadrilateral that we try to prove as a parallelogram, right? PQ is here, right? And SR is over here. Okay, right. Then again, if you consider this ABPQ parallelogram ABPQ, right? This AB side is parallel to PQ side, right? Okay, because opposite sides of a parallelogram are parallel, right? And then again, if you consider this green color one, the parallelogram ABRS, AB side is parallel to, right? Side AB is parallel to side SR, right? SR, right? So AB is parallel to SR, again the same reason. And then again you can say, therefore PQ is parallel to SR, right? Right, now notice this, right? We have proved that two sides are equal and parallel. And do you remember? It's a property of a parallelogram, right? So here we have successfully proved that this particular given quadrilateral as a parallelogram. So you need to write these steps. So we can say that in QPRS quadrilateral, PQ equals SR as well as PQ is parallel to SR. So we can say since a pair of opposite sides is equal and parallel, QPRS is a parallelogram. Okay, let's read the next question. This figure illustrates a parallelogram ABCD. Right, this is our parallelogram. If AE equals FC, this is AE and this is FC, right? Prove that EBFD is a parallelogram. So where is this EBFD quadrilateral? E, B, F, D, right? We need to connect these points and our quadrilateral, right? EB, then TF. Right. Now here is our EBFT quadrilateral. Right. Now we need to prove that this is a parallelogram as a parallelogram. Right. Now when you consider the parallelogram ABCD, right, this length and this length should be equal. Why? Because diagonals of a parallelogram bisect each other. So what are the diagonals of this parallelogram? This line and this line. And they bisect each other. So in that case, this length should be equal to this length. So let's write it. AO equals OC, right? Actually, when you consider this parallelogram ABCD, you can say AO equals OC. For some reason, diagonals of a parallelogram bisect each other, right? So that's why we say that AO equals OC. And also, it's given that AE equals FC. So let's write it. AE equals FC. So I'm going to label the first one as number 1 and next one as number 2, right? Now this is actually given data, given. So if I deduct 2 from 1, what do I get? I get this remaining lengths, right? And do you see these lines are inside our quadrilateral that we try to prove as a parallelogram, right? So let's write it. From AO, we need to deduct AE, and from OC, we need to deduct FC. So what is remaining? OE and C goes, then OF, right? Now again, if you consider ABCD parallelogram, this parallelogram, right? These two lengths should be again equal. Why? The same reason, diagonals of a parallelogram bisect each other, right? So this length and this length should be equal. And we have already proved that this length and this length as equal, right? So can you see? We have proved that the diagonals of this quadrilateral bisect each other. That means automatically this quadrilateral becomes a parallelogram, right? Diagonals bisect වෙන නිසා මෙහෙම දෙපැත්තට සමාන lengths තමයි අපිට එන්නේ. ඉතින් එහෙම තියෙනකොට අපිට කියන්න පුළුවන් අනිවාර්යෙන් මේක parallelogram එකක් කියලා. Right, so I'm going to write like this now. So this length and this length should be equal. So let's write it. DO equals OB. Same reason, diagonals of a parallelogram bisect each other. And then what can you say? Now, if you consider quadrilateral EBFD, right? OE equals OF. That means these two lengths, right? And also DO equals OF, these two lengths, right? So this means the diagonals of this quadrilateral bisect each other, right? So we can write like this: since diagonals bisect each other, EBFD is a parallelogram, right? That's the answer. Right. Seventh question. In the given figure, ABCD is a parallelogram, right? Where is our ABCD parallelogram? Where is our parallelogram ABCD? It's here. ABCD. The side DA has been produced up to X. This is side DA and it has been produced up to X, right? Such that DA equals AX. Yeah, they have marked it. These two sides are equal. These two lengths are equal. DC produced and XP produced meet at Y, right? DC is here, and when we produce it, and also when we produce XB, they meet at Y. Y is here, right? Now we need to prove that AXBC is a parallelogram. Where is AXBC? Right. AXBC. Right. That means we need to connect A and C, right? Okay, now this is our quadrilateral that we try to prove as a parallelogram. Now it's given that AD equals AX, right? AD equals AX given. And then if you consider parallelogram ABCD, right? AD is parallel to BC, right? These are parallel. Also, they are equal, right? Opposite sides of a parallelogram are equal. So AD equals BC. If AD equals AX and again AD equals BC, that means AX should be equal to BC, right? So our AX is here, right? And BC is here. So these are two opposite sides of that quadrilateral, this pink color one, right? Now, when you consider the quadrilateral AXBC pink color figure, these two lines are parallel. It's given actually, right? Can you see? It's given, right? So we can write AX is parallel to BC and given, right? It's given. And already we proved that AX equals BC. It is already proven. So we see that a pair of opposite sides is equal and parallel. So this means this quadrilateral is a parallelogram. Right, so let's write it. Since a pair of opposite sides is equal and parallel, AXBC is a parallelogram. This is Roman figure 1. Right, next question. ABYC is a parallelogram. Right, where is our quadrilateral ABYC? Let's erase everything and find out. ABYC. Right, so I need to connect C and A. Now here is our quadrilateral. Now if you consider the parallelogram AXBD, this parallelogram, this one, Roman figure 1, AC, this side, right, this line is parallel to BX, right, BX. Now we proved that this quadrilateral as a parallelogram. So the opposite sides should be parallel, right? Now if you consider the whole line, it's XY. Again, AC is parallel to XY even, right? Because this is the same line. So instead of BX, I can write XY. So I'm going to write AC is parallel to XY. Right? ඒක තේරුණා නේද දැන් BX කියන එකම තමයි extend වෙලා y ට යන්නේ. එතකොට ඒක same line එක. ඒ කියන්නේ අනිවාර්යෙන් AC XY කියන full line එකට parallel වෙනවා. Right? Right. එතකොට දැන් මෙතන parallel sign එක දාලා තියෙන්නේ මම. ඒ කියන්නේ මෙතනත් parallel නේ. ඒ කියන්නේ BY එතකොට parallel වෙන්න බෑනේ AC ට. නේද? Again, AC is parallel to BY because BY is the side of our quadrilateral that we try to prove as a parallelogram, right? So again, I can say AC is parallel to BY, right? Okay. So don't get it confused. Right now, we are inside our quadrilateral. AC is parallel to BY, right? And then what else can we see? We can see that it's given actually, as I told you in the earlier, this line is parallel to this line, right? So that means AB is parallel to DY, or you can say CY, right? So CY, and it's given, right? This is given. Okay. So if you consider this quadrilateral, right? AC is parallel to BY and AB is parallel to CY. So this means opposite sides are parallel, right? So obviously this is a parallelogram, right? This is a parallelogram, right? Let's write like this. Let's say in the quadrilateral ABYC, right? AC is parallel to BY because we found out here AC is parallel to BY. And also AB is parallel to CY and it's given already, right? So we can say that since opposite sides are parallel, ABYC is a parallelogram. Pairs of opposite sides are parallel. Okay, next question. We need to prove that DC equals CY. DC is here, CY is here. Right, now how can we prove this? Right, now when you consider the parallelogram ABCD, right? ABCD parallelogram, we know that AB equals DC, right? So let's write it. In the parallelogram ABCD, AB equals DC or CD, right? And then when you consider the parallelogram ABYC, right? The parallelogram ABYC, AB equals CY, right? AB equals CY. Right now, AB equals DC. AB equals CY. So definitely DC equals CY. Right? This is Roman figure 3. Right. Next question. The diagonals of Parallelogram PQRS intersect each other at O. The points M, T lies on PO and OR respectively, and the points L and N lies on QO and OS respectively, such that PM equals RT and SN equals QL. Right, then we need to prove three things. Right, now, first of all, we need to draw the figure, right? Okay, let's draw a parallelogram first of all. Okay, now we need to draw the diagonals. Okay, now let's label it as P, Q, R, S. Okay, here is our O, where the diagonals intersect each other. Right, then we need to mark these points, M and T, right? M on PO. Okay, let's mark M here, right? Then T on OR. And look here, PM should be equal to RT. Right, now that means we need to take similar distances, right? Then මෙතන M mark කරේ MP අතර දුරයි RT අතර දුරයි සමාන වෙනවා කියන්නේ T එකත් මේ මෙන්න මෙතෙන්ට සාමාන්‍යයෙන් equal distance එකක් length එකක් අරගෙන අපි අඳින්න වෙනවා. Roughly, right? This is our point T, right? Okay, then same thing on the other diagonal, right? L and N, L on QO, this side, right? So let's mark it. This is L, and on the other side, OS, it's N, right? So notice here, these two lengths are equal, and here also these two lengths are equal. Okay, first of all, we need to prove that MO equals OT. Where is MO? MO is here, and OT is here. Right, so we need to prove that these two lengths are equal. Right, so what to do now? Right, now this is a kind of an easy task, right? Okay, let's take the parallelogram PQRS. So we know that PO equals OR because diagonals of a parallelogram bisect each other. And then we are given that PM, this one, right? PM equals RT, right? And this is given. Now, if I label the first one as number 1 and next one as number 2, and if I deduct 2 from 1, I can obtain MO and OT, right? PO minus PM equals OR minus RT. The remaining is OM, or you can say MO. Here they have given MO, so let's write MO equals, right, RR. So remaining is OT, OT, right? So we have proved that MO equals OT. Right, let's do the next one. LMNT is a parallelogram. We need to prove that LMNT is a parallelogram. Right. Let's see where this LMNT is. Right. Now, L is here. MNT. Right, that means we need to connect these points. Okay, this is our quadrilateral. So we need to prove this as a parallelogram. Yes, again, this part we can easily prove, right? Similar to the first part, right? Now, already you know that MO equals OT. MO is here and OT is here. So this is actually the diagonal of this quadrilateral, right? And then, so in the similar way, we can prove that this NO equals OQ, right? In the same way, right? So let's do it. So when we take the parallelogram PQRS, right? SO equals OQ. Why? The diagonals of a parallelogram bisect each other. Then it's given that SN equals QL. SN equals QL. Right? This is given. So this is 1 and this is 2. And when we deduct 2 from 1, SO minus SN equals OQ minus QL, right? So what remains? ON, or let's write NO, no, right? Then OL, right? So that is actually these two lengths, right? So we are inside that quadrilateral and this is the diagonal, right? One of the diagonals. These two lengths are equal. So what can we say? In the quadrilateral LMNT, MO equals OT, NO equals OL, right? So we can say that since the diagonals bisect each other, LMNT is a parallelogram, right? So this is a parallelogram. Now next we need to prove MSTQ is a parallelogram, right? Now you can see MSTQ quadrilateral, right? Now if you consider this quadrilateral MSTQ, already we have proved that MO equals OT, right? This side, this length is equal to this length, right? And then if you consider the PQRS, the parallelogram PQRS, this is a diagonal, right? A diagonal of PQRS. So this is the diagonal of parallelogram PQRS. And we know that diagonals of a parallelogram bisect each other. So that means this length is equal to this length. So when we consider our quadrilateral MSTQ, we see that the diagonals of this quadrilateral also bisect each other. So this means this is a parallelogram, right? So next we can write SO equals OQ because diagonals of parallelogram PQRS bisect each other. Then you can say since the diagonals bisect each other, MSTQ is a parallelogram. Right, now let's discuss about 3 parallelograms with special properties. Right? These 3 parallelograms are rectangle, square, and the rhombus. These are actually parallelograms. හොඳට මතක තියාගන්න දැන් සාමාන්‍යයෙන් parallelogram එකක් මේ වගේනේ. හැබැයි rectangle, square, rhombus මේ කියන කට්ටිය parallelograms. right? හැබැයි මේගොල්ලන්ට special properties තියෙනවා. normal parallelogram එකකට වඩා. Right, let's take first of all the rectangle. Right? Now when we consider a rectangle, right, all the vertex angles are right angles. Now if you consider a normal parallelogram, this angle is not a right angle, no? Right? But when you consider a rectangle, all the vertex angles are right angles. Can you see? All these angles are vertex angles, right? Are right angles. So it's 90 degrees. And then the diagonals are equal in length. Now, when you consider a normal parallelogram, this diagonal is not obviously equal to the other diagonal, right? But when you consider a rectangle, the two diagonals are equal in length, right? Can you see? This length is equal to this length. Okay? Now, if I write like this, SQ should be equal to R. So that's the speciality. Right, what about the square? Right? Now, the square has these special properties. All the sides are equal in length. Yes, මේක නම් ඉතින් පොඩි කාලේ ඉඳන්ම දන්නවනේ. All the sides are equal in length, right? And then the diagonals bisect each other at right angles. Right, that means now these are the two diagonals. So at this intersecting point, right angles are formed. Right? So here 90 degrees, here also 90 degrees, here also 90 degrees, and here also 90 degrees. So the diagonals bisect each other at right angles, right? Next, the angles at vertices, right? That means vertex angles are bisected by diagonals. Now, can you see? Here 45 degrees, here also 45 degrees. We know that this angle is, the vertex angle is 90 degrees. And because of the diagonal, these two angles become 45 degrees each. Because this diagonal bisects this particular vertex angle. Right? So likewise, every vertex angle is bisected by the diagonals. Here, here, and here. Right? Here 45 degrees, 45 degrees. Also the same here and here. So these are the special properties of a square. Also remember, similar to the rectangle, the diagonals are equal in length. Right? Can you see these marks? Diagonals are equal in length, like the rectangle. Okay? And then let's talk about the rhombus. Right, now when you take the rhombus, all the sides are equal to each other, like our square, right? All the sides are equal to each other, right? So these sides are equal in length, okay? And then the diagonals bisect each other at right angles, just like the square, right? So this is one of the diagonal, this is the other diagonal, and they bisect each other at right angles. So here 90 degrees, here and here 90 degrees, right? And then the angles at the vertices are bisected by the diagonals. Now remember this. Now this is similar to square, but right, you don't get 45 degrees after bisection, right? It's something else, right? Can you see? Obviously, the vertex angles are bisected by the diagonals, but we don't get 45 degrees like the square. it can be some other degree value. And this angle should be different, right? Right now, when you take a square, right? If you take a square, now this is a special parallelogram, no? If you push on this side, right? This will become a rhombus, right? Like this. Now again, if you take a rectangle and push on this side, you will get the normal parallelogram that you get in, sums and the questions. So opposite sides are equal. Here also opposite sides are equal. So this is square. When you push a square, it will turn into a rhombus. Right? This is a rectangle. Once you push on one side, the rectangle will turn into a normal parallelogram that you get in your questions. Right? Okay? So understand the difference. So the square, the rectangle, and the rhombus have special properties than the normal properties of a parallelogram. Okay? හරි නේද මේ concept එක තේරුණා නේද? දැන් අපි දන්නවා square එක කියන්නේ special parallelogram එකක්. මේකේ එක side එකකට හිතන්න තල්ලු කළා, push තල්ලු කළා. හරි එතකොට rhombus එකක් අපිට එන්නේ. rectangle එකේ පැත්තකට තල්ලුවක් දැම්මොත් ඔන්න අපිට එනවා අර අපි සාමාන්‍යයෙන් paper එකේ question වල එන normal parallelogram එක. Right, now let's discuss the activities in the miscellaneous exercise. Question number 1. ABCD in the figure is a parallelogram. This is ABCD parallelogram. If DF equals EB, this is DF and this is EB. Prove that AECF is a parallelogram. AECF. This quadrilateral. Right, now how can we prove this? Right, now consider this side and this side, right? If you consider the parallelogram ABD, right? This DC side equals AB, right? Because opposite sides are equal. So you can write opposite sides of a parallelogram are equal. Then it's given that DF equals EP. Given, right? Now, if the first one is number 1 and the next one is number 2, if I deduct 2 from 1, what do I get? DC minus DF. So I get CF, or you can say FC, right? From AB, if I deduct EB, I get AB. So FC equals AB. So where is this FC and AB? These are the sides of that our quadrilateral, right? Right, now it's given that these two sides are parallel. So obviously, this has to be a parallelogram because there is a pair of opposite sides which are equal and parallel. So you can write like this. FC is parallel to AB and it's given actually since a pair of opposite sides are equal and parallel. AEF is a parallelogram, right? Easy one. Right, next question. In the triangle ABC, the bisector of ABC meets the side AC. Right, seems like we need to draw our figure, right? So let's draw this. We need to draw first of all a triangle. Okay, let's label it A, B, C. Angle ABC meets the side AC at point P, right? Bisector of angle ABC. So let's draw the bisector. So this point is P. Then the straight line through A drawn parallel to BC. Right, now we need to draw a straight line through A which is parallel to BC. Right, let's draw it. Right, next meets BP produce at D such that BP equals PD. So we need to produce BP and it meets at D. So here is our D. Okay. Now BP equals PD. So let's mark BP equals PD. Right. First we need to prove that BCP, triangle BCP is congruent to triangle ADP. Right. Where are these triangles? BCP, it's here. Right. This is the triangle. And ADP, it's over here. Right. So we need to prove that these two triangles are congruent. Right. Already we know that PP equals PD because it's given. Right. And what else do we know? Now these two lines are parallel. Right. So we need to mark using the arrowhead. These two lines are parallel. Now if these two lines are parallel, this angle should be equal to this angle. Right? Because they are alternate angles. And what about these two angles? These are also equal because these are vertically opposite angles. So obviously, these two triangles are congruent under the case of AAS, right? Two pairs of angles and one pair of sides. Right, so let's write triangle BCP in triangle BCP and triangle ADP. Let's write the pairs of angles first of all. Angle PBC, right? PBC equals ADP, right? PBC, this angle, and ADP, it's here, this one. This is because alternate angles. And then next pair of angles, angle BPC, this angle, BPC equals angle APD, angle over here, right? This is because vertically opposite angles. And then it's given that here BP equals PD. Therefore, we can say triangle BCP is congruent to triangle ADP. Right, this is Roman figure 1. Let's write the case also under AAS case. Angle, angle, side. Right, now let's do the next question. Show that ABCD is a rhombus. Right. Do you remember the rhombus? It's a parallelogram that has special properties, right? So one of the properties is all the sides are equal. In a rhombus, all the sides are equal. So if we can prove that all the sides are equal in ABCD, we can easily prove that ABCD is a rhombus. Okay, so let's try to do it. Right, first of all, we need to find out this quadrilateral. A, B, C, D. So that means we need to connect C and D. Okay, remember, first of all, we need to prove that this quadrilateral is a parallelogram, right? Then only we try to prove that that parallelogram is a rhombus. Okay, so we write quadrilateral ABCD. Now it's given that BP equals PD. So we write BP equals PD given within brackets. Then we can say AP equals PC. Now can you see the diagonals of this quadrilateral bisect each other, right? So that means this is a parallelogram. So we write, since diagonals bisect each other, ABCD is a parallelogram, right? It's a parallelogram. Right, now let's try to prove that this parallelogram is a rhombus, okay? Right, now when you consider this figure, you see that these two lines are parallel. If these two lines are parallel, these two angles should be equal. So that means PBC, angle PBC equals angle ADP. And they are alternate angles since AD is parallel to BC. Now we know that BD or BP is the bisector of angle ABC. So that means this angle and this angle should be equal, right? So we can say PBC equals ABP. It's here, ABP, right? Right. Then when you consider the triangle ABD, where is our triangle? ABD is here, right? Can you see these two angles are equal? If these two angles are equal, their opposite sides should be equal, right? So what's the theorem? Sides opposite equal angles are equal, right? So you can write saying this ADP angle equals ABP. That means these angles, right? So therefore, AB, this side, equals AD, this side, right? Because sides opposite equal angles are equal. So this is converse theorem of isosceles triangles. Do you remember? Right. Then you can say simply, since two adjacent sides of a parallelogram are equal. Now, what are the two adjacent sides? These two adjacent sides, right? Now, when it comes to a rhombus, if two adjacent sides of a parallelogram are equal in length, right? That means that parallelogram is a rhombus, because eventually all four sides become equal if two adjacent sides are equal. So remember it, right? ඒ කියන්නේ දැන් rhombus එක සාමාන්‍යයෙන් rhombus එකක් කොහොමත් parallelogram එකක් නේ. ඒතකොට rhombus එක යාබද පාද එහෙම නැත්නම් ළඟ ඉන්න sides දෙන්නේ සමාන නම් equal නම් අනිවාර්යෙන් sides හතරම සමාන වෙනවා. ඒතකොට sides හතරම සමාන වෙනවා කියන්නේ ඒක rhombus එකක් නේ. right? එතකොට අපිට adjacent sides දෙන්නේ සමානයි කියලා පෙන්න ගන්න පුළුවන් නම් ඒක rhombus එකක් කියලා අනිවාර්යෙන් ඔප්පු කරන්න පුළුවන්. Right? So we write, since two adjacent sides of a parallelogram are equal in length, ABCD is a rhombus. So this is how we prove it. Okay? Right. Next part. If AC equals 18 centimeters. Yes, Mark. AC is here. So the length of AC is 18 centimeters. So this means AP is 9 centimeters and PC is 9 centimeters because these two lengths are equal. And this is one of the diagonal of ABCD parallelogram, the rhombus, right? And then it says BD length is 24 centimeters, right? BD means it's here. The full length is 24 centimeters means BP is 12 centimeters and PD is 12 centimeters, right? Again, BD is one of the diagonals of this parallelogram, right? And diagonals bisect each other, right? And previously we have proved that these lengths are equal. So it should be 12 each and 9 each, right? Now we need to find the length of AB. This is the length of AB, right? Now this means one side of the rhombus. All sides are equal. So we need to find the length of one side of this rhombus. Right, now when you consider this triangle, what type of a triangle is this? This is exactly a right angle, right? Okay, this is a right angle, neither. Why? Because we know this angle is a right angle. Why? Because diagonals of a rhombus bisect each other at right angles, right? Okay, so what do you have here? It's a right angle. If you have a right angle, this AB side becomes the hypotenuse, right? So how do you find the length of the hypotenuse of this right angle? Simply you apply Pythagorean relation, right? Pythagoras theorem. Okay, so let's find out the length of AB. So what's the Pythagoras theorem? AB squared equals 9 squared plus 12 squared. What's 9 squared? 9 times 9, 81. 12 squared, 144. So when you add 2, 225. AB squared equals 225. That means AB equals square root of 225. So you get 15 for AB. So this could be a positive value or a negative value when it comes to the square root. But we know the length is a positive value. So we can say AB equals 15 centimeters. So in this rhombus, each side is 15 centimeters. Okay, right. Let's move on to the next question. In the triangle ABC, midpoints of side AB and AC are respectively X and Y. Right, now here also we need to draw the diagram, draw the figure. Right, let's draw a triangle first. Let's label it A, B, C. The midpoint of AB, X, right? Midpoint of AB is X. Then midpoint of AC is Y. It's Y here. The straight line drawn from through C parallel to AB meets XY produced at C. Right. The straight line drawn through C parallel to AB. So here we need to draw a straight line through C, which is parallel to AB. Right, let's draw. Now let's mark. These lines are parallel now. And it says meets XY produce at C. So we need to produce XY. Okay, like this. And this is Z. Prove that AXY, triangle AXY congruent is congruent to triangle CYZ. Right. So where are these triangles? AXY XY is here, right? Then CYZ, right? It's over here. හරි නේද? මේ ඉන්නේ triangles ලා දෙන්න. දැන් මේ දෙන්න congruent කියලා prove කරමු. Right? Okay. Now, if you consider these two triangles, we can say definitely these two sides are equal. Why? Because Y is the midpoint of AC. Then, if you consider these two angles, these are vertically opposite angles. Okay, so they should be equal. When you consider these two lines, these are parallel lines. Since these two lines are parallel, you can say that this angle and this angle is equal, right? Because these are alternate angles. Now, what's the case here? Two pairs of angles and one pair of sides, right? That means AAS, right? AAS. These two triangles are congruent according to AAS. So let's write the steps. In triangle AXY and CYZ, right? XAY, this angle, right? Should be equal to YCZ, this angle, right? Because alternate angles. Then these two angles, they are vertically opposite angles. AYX and CYZ. And also AY equals YC because Y is the midpoint, right? Y is the midpoint of AC. Therefore, we can say these two triangles are congruent. The case is AAS, angle, side. Okay. Now, what's the other question? ABZX is a parallelogram, right? Now, let's erase everything and find out where ABZX is. PCZX. So let's try to prove this quadrilateral as a parallelogram. Now, what can you say when you consider the quadrilateral BCZX? So when you take the congruent triangles, right, the corresponding elements should be equal. So we can say that AX equals CZ, right? Where is AX? It's here. And CZ is here, right? So these should be equal, right? Because of congruent triangles. And then AX should be equal to BX because X is the midpoint of AB, right? So these two sides should be equal. So AX equals CZ, AX equal BX, that means ZZ, right? CZ or CZ should be equal to BX. So where are these sides? ZZ is here, right? BX is here. So these are the two opposite sides of this particular quadrilateral, right? So we have found that two opposite sides are equal. Then if these two opposite sides are parallel, definitely this has to be a parallelogram. Of course, these sides are parallel because it's given. It's given in the question, right? So CZ is parallel to BX. Can you see? We mark this, right? These are our arrowheads, right? So you can say since a pair of opposite sides is equal and parallel, this is a parallelogram. So this is Roman figure 2 of question number 3, right? Right. Now let's do the next question. Okay, again, we need to draw a diagram. Let's read. In the parallelogram ABCD, midpoints of sides AB, BC, CD, AD are PQRS respectively. Prove that. There are two things to prove. Right. First of all, let's draw the parallelogram. AB, CD. Right. Let's mark the midpoints. AB, midpoint is P. Here it's P. Then BC midpoint is Q. BC, Q. Then R on CD side. And then S on AD side. Right. The first question is triangle ASP. ASP here. Right. Let's connect. Then triangle CQR. CQR. Let's connect. Now we should prove that these two triangles are congruent. Okay, let's do it. Okay, now since P is the midpoint of AB, these two lengths should be equal. So what's the opposite side of AB? It's CD. So here again, these two lengths should be equal. Why? Because R is the midpoint. And then when you consider the other two opposite sides of this parallelogram, right? This length should be equal to this length. And here also, these two lengths should be equal. Right? Now that means if this is 5 centimeters, this should be 5 centimeters. And the opposite side also should be 5 centimeters each. Right? Okay. Now with that information, we can write these steps. Right? You can say in triangle ASP and triangle CQR, AC equals CQ, right? AS is here, right? And CQ is here. So with the lines, you can understand that these two lengths are equal with these double lines, right? And then AP equals CR, right? AP is here, this length, single line. And again, CR is here, right? This length. So these should be equal. So the reason is the midpoint, right? Because of the midpoint only, these sides become equal, right? Then, if you consider this angle and this angle, they should be equal. Why? Opposite angles of a parallelogram are equal. So this angle is ASP, right? And this angle is QCR or RCQ, right? And you should write the reason as opposite angles of a parallelogram are equal. Right. Now, see, you have two pairs of sides, one pair of angles. And this angle is the included angle. This is the included angle. So we can say that, therefore, these two triangles are congruent under the case side, angle, side. Okay, right. Now, next question. We need to prove that PQRS is a parallelogram. Right, where is our PQRS? PQRS. Right, this means we need to join RS and PQ. Okay, here is our quadrilateral PQRS, right? So how do we prove that this is a parallelogram? Right, now when you consider the side PS and side QR, they're actually equal. Why they are equal? Because of the congruent triangles, right? So you can say corresponding sides of congruent triangles. Then, now in the similar way, similarly, we can prove that this triangle and this triangle are congruent. අර කලින් triangles දෙන්න congruent කියලා ඔප්පු කරපු විදිහටම දැන් අපි අනිත් දෙපැත්තේ ඉන්න triangles දෙන්නවත් ඔප්පු කරන්න බලනවා congruent කියලා. Right, so we can write inside. So when we consider the triangle SDR and the triangle PBQ, right, we can write that DR, right, that means this side equals PB, this side, right, DR equals PB. And also we can write SD equals BQ, right? So this is because the midpoints, right? And then these two angles are equal, right? What are these angles? This SDR and PBQ. Why? Because opposite angles of a parallelogram are equal. Now already ABCD is a parallelogram. So these two angles are the opposite angles of this ABCD parallelogram. So then you can say that these two triangles are congruent based on same case ASA. Two pairs of sides and one pair of angle, and this angle is the included angle. Right, now because of the congruence, right, we can say that this RS side equals PQ side, right, side PQ. Side RS equals side PQ, right, because again corresponding sides of congruent triangles. මේ මෙතන කරපු දෙයම තමයි දැන් අපි මෙතන මේ triangles දෙන්න use කරලා කියන්න යන්නේ. Right, then when you consider the quadrilateral PQRS, we see that opposite sides are equal, right? This side is equal to this side and the other two opposite sides are equal, right? So you can write again if you want in the quadrilateral PQRS, PS equals to QR, this step, and we have proved it, right? And then RS equals PQ, and then you can say since opposite sides are equal, PQRS is a parallelogram. Okay, then see you in another video. Don't forget to subscribe.